Okay, so today we're going to still work on lesson 2, but today instead of graphing the exponential functions, we're going to solve them. So here's my first example, and the first examples we're going to do, like the first 10 or 12, we're looking for an exponent or a variable that's in an exponent. Now, the technique that we're going to be using to find this exponent is we're going to change the base of both sides of the equation so it's the same. Now, on this first example, you could probably look at this and guess and test and figure out what x is. You really don't need to change the base here, because I know most of you can look at this and tell me that 2 to the third power is 8, and that's what x equals. But the technique that we're going to use when the problems get a little more difficult is we're going to change both the left side and the right side to make that the base is an equivalent base. So here I'm going to change the 8, and I'm going to make this 2 to the third power, because 2 to the third power equals 8. And then over here, just rewrite this side because it already has a base of 2. Once the bases are the same, we can get rid of the base and then solve what remains. Now, on this particular problem, there was nothing to solve. It was just x equals 3, and that's our answer. Now, whenever we're solving any of these problems, we can always take our answer and we can plug it back in. If it does not give us an equivalent an equation that works out, then we know we've done something wrong. So if I take out the x and put in 3, I do see that 2 to the third power is 8, 8 equals 8, so it did check. So if you do have time on the quiz, you could plug it back in. The next one. Now, common mistakes, and this is what was happening in my C period. They're like, but can we just divide it by 2? No, you can't divide it by 2. We're looking for a base raised to some power that's equivalent to 8, and another one with the same base that's equivalent to 16. So we just did the 8. I could change the 8 to 2 to the third power. Everybody with me on that? Okay, what could I change the 16 into so it has a base of 2? 2 to the fourth. So this is my goal, is to change the numbers in the problem so that they have the same base raised to some different exponent. Now that I've changed the 8 to a 2 to the third and the 16 to a 2 to the fourth, let me put back the rest of the problem. So I've already changed the 8. It was 2 to the third, so now I put back the x. I've changed the 16 to 2 to the fourth, so let me put back the x minus 1. So again, once you change the bases so that they're the same number, get rid of the base, and now I'm going to work what remains. Now this is where our rules for working with exponents come in. We learned these at the beginning of the year. Whenever you have a power raised to another power, we multiply them. So this becomes 3 times x. This side becomes 4 times the x minus 1. So 3 times x is 3x. For this, the right side, I need to distribute the 4. And now I have an equation that I can solve for x. I'm going to move my 4x to the left. Doesn't matter which way you move things around, you'll still get the same answer. I get negative 1x equals negative 4. Divide by negative 1, and x equals positive 4. Now again, if you want to check this, you can go back to the original, the 8 raised to the x power, 16 to the x minus 1, 8 to the fourth, 16 to the 4 minus 1. So here you would do 8 times 8 times 8 times 8, and you would get 4,096. Here this is 16 to the third, so 16 times 16 times 16 is also 4,096. So because I got the same answer, I know that x equals 4 is the correct answer to this problem. Let's try the next one. What base are we going to make both the left side and the right side? 2. Okay, the left side's already done, so let me just rewrite that. And then again, I need to change the 8, so it has a base of 2. So I'm going to change the 8 to 2 to the third, and then rewrite the exponent that's left. Because what I did here was I took out the 8, and I replaced it with 2 to the third power. So now that I've got the bases are the same, I can cross off the 2's and now work with what remains. So on the left side, I just bring down the x plus 4. On the right side, I need to distribute or multiply the 3 times the x minus 6. So x plus 4, distribute, and now solve for x. And again, it doesn't matter if I move the 3x over to the x or the x over to the 3x. I'm going to get the same answer either way. So I move the x over, so now I have to move the 18 to the 4. I get 22 is equal to 2x, divide by 2, and x equals 11. Yeah, the next one. So far, we've only seen base 2, so let's change it up a little. Let's see what this base is going to be. What do you think? No? 5. Okay, so this 5 on the right side, I'm assuming it has a base, an exponent of 1. The 125, 5 to what power gives me 125?
5.
No? 3. 5 times 5 is 25, times 5 again is 125. So 5 to the third power. And now, see, you're jumping ahead. You've already given the answer. Okay, so let's go ahead and solve this now. So now I have the same base, so I can get rid of the 5. Now, notice how I put the 1 on that 5, because I need the 1 to make my equation. So now I multiply the 3 times the x and set it equal to the 1. 3x equals 1. Divide by 3, and x equals 1/3. So what Jacob did was Jacob already had given us the answer. He told us what x equals. So if we plug it in, if I take 125 and I raise that to the 1/3 power, remember the bottom of the fraction is the root and the top is the exponent. So what I'm doing here is the cubed root of 125 and then raise that to the first power. Cubed root of 125 is 5. 5 to the first power is just 5, which is what I was trying to get. We'll have fractions as our answers, and we will also have negative numbers. And that's going to be a clue for the next example. Okay, so let's take a look at this. What do you think we could change the base into? 2/3. Okay, so if you recall, when you have a fraction raised to a negative exponent, remember it flips it to the reciprocal. So I'm going to change the 9/4 and I'm going to make this 2/3, but I'm going to raise it to the -2 power because that will flip it. So 2/3 to the -2 power, you flip it, make the exponent positive, and now that gives me what I was trying to make. So then now 2/3 to the x, put that one back. I have the same base, and now I solve what remains. So x to the -2, x equals -2. So again, what you should do is look at the problem before you start to see if maybe the base you're trying to make it is already there, and then manipulate the other answer so it matches. Try the next one. What base are we going to make both the left and the right side have? 5. Okay, the left side's good to go. It already has a base 5. So let me just write that down. What can I change 25 into? 5 to what power? Squared. Good. So they have the same base. Get rid of the 5s. Work with what remains. And now solve for x. Subtract 1. 2x equals 1. Divide by 2. And x equals 1/2. So again, you could plug it in, double check it. If I plug it up here, 2 to the times 1/2 plus 1. 2 times 1/2 is 1. 1 plus 1 is 2. 5 squared is 25. So it worked out. So at the bottom, I'm going to introduce to you the irrational number of the letter E. E is like pi. Pi is an irrational number. If you look at my poster over there when it says, when it comes to numbers, pi takes the cake, and that's all the digits of pi, they haven't even found the end of it. So this is the same situation. This is an irrational number that goes on forever. Our approximation for pi, whenever we were doing it in geometry, we would always approximate it at 3.14. So for E, the approximation that you'll commonly see is 2.718. Now, we're going to be using this letter E in the last 3 examples. We're going to be learning 2 interest formulas, and one of the formulas has the letter E in it. And we're going to be using our calculators for the letter E. Now, you can find the letter E on your calculator. It's located on the division sign. So what you're going to have to do is hit second and then the division. And once you do that, it's going to show the letter E on your calculator. If you hit enter, it will show you the value of E. It's like 2.71818, and it goes on forever. The other place where you can see the letter E on your calculator is on the button LN. So you're going to hit second and LN, and that's going to open up E to some power. And that's going to be the button we're going to be using, because in our interest formulas, we're going to be raising E as a base to some power. All right, so let's keep finding these variables that are located in the exponent. Now, I know I just showed you on your calculator where the button for the letter E is. However, this would be a question you could get on the quiz, but we wouldn't be using our calculator. Remember, we're trying to make the bases the same. So in this question, are our bases already the same? Yeah. They both have the letter E. So all I have to do is get rid of that letter E, and now I'm going to work with what remains. So on the left side, just the 3 minus x drops down. Remember, on this right side, this is multiply. I'm multiplying 3 times negative x, so this will give me negative 3x. And now I can solve for x. I'll go ahead and move my x over to the right, get negative 2x, divide by negative 2, and x equals negative 3/2. And again, you could plug it back in and make sure it works as a double check. What can we change 32 and 16 into so they have the same base? 2. Here we go again with the 2. Because I know that 2 to the 5th power is 32. And 2 to the 4th power is 16. Now, someone in my other class said, could we change it to a different base, like a 4? Well, there isn't any number that will give me 4 to what power would give me 32. I know 4 squared would give me 16, but I can't raise 4 to any power to get a 32. So that's why it has to be 2. They both have a base of 2. I can now get rid of that base 2, and I work with what remains. So 5 times x, 4 times 1 minus x, multiply them, and now combine my like terms. I'll move the 4x to the left and divide by 9. And my answer is 4/9. All right, number 9. What is my base going to be? 1/2? 2. Okay, what can I change the 1/2 into? 2 to what power? -1. Nice. So 2 to the -1. Rewrite the exponent that's already there. My right side is good. Let me just rewrite it. I'm going to get rid of only the base. So I get rid of the 2. And now I multiply what remains. So the -1 times the 3x minus 6. And the 3 times the x plus 1. I'm going to distribute. And now begin to combine my like terms. I'll add 3x. Subtract the 3. Three equals 6x. Divide by 6. So x equals 1/2. What do you think my common base, or what is the base I'm going to change it to? E, good. So the first one's good to go. The right side, it's going to become e to what power? -4. So the number that's down there. Everybody with me on that? So we're sort of working backwards. We're so used to turning negative exponents into fractions. Now what I need to do is turn that fraction into a negative exponent so that my base is the same. So when you're looking at the problem, if you see a fraction, change it to a negative exponent. So that way the bases will become the same. So now I can get rid of the letter E and now work with what remains. Distribute the -4. And now begin to combine my like terms. I'm going to add 4x. Add 1. And divide by 5. So x is equal to -3/5. What's going to be my base that I'm going to change these to? 5. Good. So again, remember the root. When it's a root, we're going to change it into a fraction exponent. So this will become 5 to the 1/3. Rewrite in the -x still. And then this will become 5 to the -1. I can get rid of the 5 and now work with what remains. So 1/3 times -x, -1 times x plus 2. So -1/3 x, -x minus 2. Need to get my x's together, so I'm going to add 1x. Over here, I'm going to change the 1x into 3/3, just so it's easier to see the subtraction. I now need to divide by 2/3. Remember, dividing by 2/3 is the same as multiplying by the reciprocal. So if I multiply both sides by the reciprocal, this cancels, so I'm left with x is equal to -3. So far, these first 11 examples that we did, noticed all of the variables were in the exponents. Now, starting at example 12, now we're looking for a base. And we sort of did this at the beginning of the year. Okay, we did examples where we were looking for a base. So what I'm going to do for this one is I'm going to go back to what I used to thinking is I'm going to change the x to the -4 into a positive exponent. And now I've created a proportion. So I'm just going to do cross products here. Multiply diagonally. I get 1 times x to the 4th, 1 times 81. And now I go back to what I did at the beginning. To find, I got to figure out what is the, I'm going to do the 4th root of both sides. And x equals plus and minus 3. Whenever you're doing an even root, remember we get 2 answers. These next 2 examples are similar to what we did at the beginning of the year. Remember, we multiply by the reciprocal of that power, or we raise both sides to the reciprocal. Because remember, whenever you multiply a fraction by its reciprocal, it becomes 1. So the product of a fraction and its reciprocal gives you 1. So this causes this exponent to become x to the 1st. Whatever I do to one side, I need to do to the other side. I need to keep things balanced. So this really becomes the 4th root of 81, and then I cube that answer. Now sometimes you have to do the exponent first, but most of the time it's easier to do the root first. Otherwise you're going to get a really huge number that you're going to have to find the root of. So I'm going to find the 4th root of 81, which again is plus and minus 3. And then I raise that answer to the 3rd power. So this becomes plus and minus 27. We did these at the beginning of the year. We're going to do the same thing on the next one. We're going to raise both sides to the reciprocal power. So the reciprocal power would be 2 over 5. So this becomes x. I'm going to be taking the 5th root of 32 and squaring it. Now, when it's an odd root, I don't take the plus and minus answer. I only take whatever answer of the root it is. So this is just positive 2, and then I square that. So x equals 4. These interest questions. All right. So you probably already covered interest in middle school, but the interest formulas, and some schools actually do the compound interest in middle school. You probably just did simple interest in middle school, and that formula is I equals PRT. Okay, the P, the R, and the T are the same variables that are in these 2 formulas. The P is the principal, or the amount of money that's invested. The R is the rate. It's the number next to the percent sign. The rate is also going to be converted to a decimal when we use it in the formula. And the time is always in years. So if in the problem they tell you it's 6 months, we need to convert that to part of a year. And we know that there are 12 months in a year. So 6 months is equivalent to 1/2 or 0.5. So whenever they give you the time in months, make sure you make it to part of a year. Okay? But if it's just 5 years or 10 years, you just use that number. Everybody with me on that? All right. The second formula, so the first formula, my acronym for this is called the PERT formula. So whenever you see the word continuous in the problem, you know you're using the PERT formula. Whenever you see any of these special words like semi-annually, quarterly, annually, monthly, and I know annually is not on here, but annually means once a year. Okay, so whenever you see any of those words, you know that it's going to be compounded. So they're going to say, this problem is compounded quarterly. And you need to memorize that quarterly means 4, annually means 1, semi-annually 2, monthly means 12. So again, the P is the same, the R is the rate, the number with the percent sign, the M is these numbers here that match those words. And then the T is still the time in years. So let's try an example of each. Now what I want you to do is, as you're putting this or writing this down, practice keying it in your calculator. So let's try the first example. So I've told you the formula we're using. Notice the word continuous. So this tells me I'm using that PERT formula. So the 5,000 is my P, my principal, or my amount of money that I'm investing. The 3% I need to convert to a decimal. I convert a percent to a decimal by taking away the percent sign and moving that decimal point 2 times to the left. So the percent needs to be made into a decimal. Continuous, this just tells me I use the PERT formula, and the 5 years is my T. So let's replace. I'm solving for A. My P is 5,000. My E is the button I'm going to hit on my calculator, and then I'm going to raise that to the 0.03 times 5 power. So you can key this continuous in your calculator. You're going to key 5,000 times, then you're going to hit the second ln key, so that'll open up e to some power, and then you're going to hit 0.03 times 5. You should get the number $5,809.17. We are going to round it to the hundreds place because this is money. Okay, the second formula, we're using the A equals P times 1 plus R over M TM. So the P is 1,000. I'm going to change the percent into a decimal, make it 0.04. Quarterly means 4 times, so that's my M value. And then my T is 10. So let's replace these numbers. So A equals 1,000 times 1 plus, my R is 0.04, quarterly is 4, raised to the 10 times 4 power. So you should be able to key this continuous in your calculator. If not, you can divide the 0.04 by 4 first, add 1 to it, raise that to the 40th power, and then times by 1,000. So depending on your calculator. This should approximately, because we're rounding it because it's money, is approximately equal to $1,488.86. All right, last one. Notice the words compounded annually. So this tells me I'm using the bottom formula. So I'm going to be using the A equals P 1 plus R over M raised to the TM formula. So again, this time they already gave me the interest. So then I'm going to do P, leave the P there, 1 plus. Again, we need to change this 3.01 into a decimal. So it's going to become 0.031. It's annually, so that becomes a 1. My time here is 5 years. And again, it's still annually. Now, if you want to simplify some of this down, you can. This just becomes 1.031 raised to the 5th power. And I'm solving for P. So all I need to do is divide both sides by 1.031 raised to the 5th power. And you can do this in your calculator continuous. So I would do 6,000 divided by 1.031 to the 5th power. And you should get approximately $5,150.60. Remember, this was your initial investment. It needs to be less than the interest or the total amount in the account. If you're getting a number that's bigger than 6,000, you've done something wrong. Because we were looking for the P here, or the initial amount invested. Okay, so homework is these problems. It's due on Thursday. However, I highly recommend you at least start it tonight, and this way if you have questions, I can help you get ready for the quiz.